Hi everyone, welcome back to this channel. In this quick video, I'm going to walk through different measurement method when you want to measure a modulated signal. For example, a 40 MHz wide bandwidth of a 16 QAM signal. So what I have here on the right side, as you can see, is two ports N5186A new MXG. So it's a bit different from the previous video because this is a two-port options. Nevertheless, the whole setup will be the same. So just a quick review, this is how the setup looks like on the hardware side. So I have a power splitter connected to the output of channel 1 of the MXG, and one port of the power splitter is connected to a power sensor, which is an average type power sensor U2008, and that sensor is connected to Fieldfox as a power meter, and the other side of the power splitter is connected directly to a EXA. So I'm going to walk through with you quickly on how to set up the 16 QAM 40 meg bandwidth signal. Before that, we just want to calibrate, just to make sure the offset has been counted for. And this is what I will do normally. So I'll set the frequency and I'll set the power output from the signal generator. So let's turn that on. And we go to EXA, so this is a spectrum analyzer mode. We go to auto tune. So you should see something like this. So the auto tune is very useful when you have one single signal in the whole spectrum and you auto detect and set up to the best view setup. So as you can see, I'm pumping out at 0 dBm and I'm measuring at -6.41. So for that path from signal generator connect to the power splitter, and from the power splitter with the cables, so we are talking about 6.4 dB offset. Let's add that in. Let's go to measure, input output, corrections. So correction is more complicated. So since we are doing just one point of measurements as a proof of concept, so let's change that. So 6.4. So if you put a minus here, it's a loss. So you compensate back that 0 dBm. So we have a loss of 6.4 dB, and this being calculated. If you want to be more accurate, so we can do a 6.06. So 0 dBm, 0 dBm. Okay, then the next thing I want to do is to set up a signal, a modulated signal here. So I've done this, but I can walk through with you on this. On the N5186, you can go to custom modulations and let's select QAM, and then we go to modulation config. So these are very basic setup. So all the data inside is just a pseudo random formations. So we set it to 40 meg. So it's roughly that. Number of symbol you can change, or you can just leave it as it is. So I want 16 QAM. So OK, and generate. So you auto download the waveform file, and let's go to here. So this is a waveform, but my modulation is off. So let's turn that on. So modulation is on, and because my span is quite small, you won't be able to see all those. So let's set it to 17. There you go. So this is how it looks like, as simple as what we have seen. So you might notice that the power level at this point is not really 0, which makes sense because the 0 power is actually the combinations of the whole 40 meg power. How do we measure that? Two ways. Let's go to marker. In most of the spectrum analyzer, we have this marker function called a band power measurements. So this is where you can set it to, because our signal is roughly about 40 meg, 3 dB. So it's roughly around there, but you can actually expand it even further because of the roll off. So 3 dB roughly about somewhere here. So yeah, 47-ish. You can see that the power level is quite close to 0 dBm as it's pumped out from the signal generator. So this is one way of doing the measurements. Another way is go to the channel power options. So we get that is spectrum analyzer, channel power. Okay, essentially the same thing. So what we need to do is to change the span to 70 meg. So you can see that the next thing we want to do is we change the analysis bandwidth, measurement setup. So we set it to 47 as what we did just now. and we can change back the span to something lower, something back. So the power, channel power is about 0.0. Another things you can do if you're not sure about the bandwidth, you can go with this occupied bandwidth. I think I covered this in the previous video with the Firefox, but nevertheless it's good to look back. So as you can see, occupied bandwidth is about 50 meg at 3 dB raw. So with these informations, let's put back here, so you can change that. Yeah, 50.8 megahertz, so it's very close to 0. So we also can change here 50.8 megahertz. It's roughly that. So you might ask, what is the result are we going to see on the power sensor? So we go back to the Firefox. Let's turn off the modulations for now. So because we want to measure the offset, just remember this sensor is connecting directly to the power splitter without the additional jumper cable, so it might be lower than what we put in the spectrometer part. So I'm pumping at 1 gig, 0 dBm, 1 gig, but I'm getting at this number. Let's set it back to 0 first, and this offset. There's something different with the Firefox setup, so you have to just type 6.28 instead of the negative, because it will just add on to that. So again, these are 1 point measurements at 0 dBm. Let's turn on the modulations, so you can see that it's still the same. So you can see that the reading is going up because the average turned on here, but the concept is the same. So when we say that modulated signal pumping out at 0 dBm, the power should be close to 0 dBm. And then if we turn off the modulations, it will be just CW. When you pump at 0 dBm, it should get 0 dBm. I hope this clarifies something here, and hope this helped. Thanks for watching.